So this is going through additional dimensions. So I'm going to start with something blank. And so to do that, I'm going to start with random, and I'm going to put them all at 0. So 0, 0, 0. So all of those dots are now contained within this one dot. Okay. So that's where we are. And so essentially what that does is additional dimensions is now the driver of position, which we call micro offsets. So width, height, depth in the Cartesian plane, or we can do spherical coordinates, or you can do cylindrical coordinates. And I'll go through different examples of some of those options. But I'll stick with Cartesian now just because it's the easiest way to understand X, Y, Z dimensions. So I can essentially rebuild the exact same thing I just made by doing this manually, if that's the right word. And so I'm setting the min and max, and that is the amount of offset from its original position based on these values, which is essentially the same way that a scatter plot works, but you have more control over those mins and maxes and what values are here. And it's not recognizing this as a year, it is actually recognizing it as a number. So that's one sort of limitation to call out that we don't have the checkbox for is time based. Now, I'll do life expectancy on the height axis, and same way I'm starting to build it. The notable things are obvious, like there's no axes lines. You'll note that's because of the way that's built is not tied to additional dimensions, but tied to the scatter plot function. So I can go through some of that. But what this allows you to do, and it's insanely powerful, and we're trying to figure out what's the best way to really teach it or show it. And so one such example of how this can look. Oh, gosh, I'm sorry. I've just been jumping. Uh-oh. No, that's okay. No. So one such example is, this is basically a jumbled sea of lines. And so if I have a map as an example, and let me make this map actually let's, I'm going to do equirectangular. I'm going to make it a little bigger, and I'm going to make it flat. Great. So one thing we could do here is that because we've defined the offsets based on the additional dimensions, we can set the position of the dots based on using this the regular function. So I could map to regions using map1 and tell it the region column to look at, which I think is called region. Or no, yeah, region. Nope, not region. Country, just country. Okay, so now essentially over each country is the life expectancy graph now. So that's sort of one emergent use case in some sense, that you're combining geospatial data with time series data. So there's things that you can start to explore that look at that essentially. And now that I've looked at this, let me try one thing while I have everyone. Yeah, so you'll see how, like, as I rotate this map, it's sticking with it to go around. But so that's one such sort of use case or primer of some of the objectives of it. Now I'm going to go back and change this. I'll just add a step and change this back to random and keep it at 0, 0, 0. And I'm going to turn off these additional micro offsets so that we're back to our singular dot. There we go, back to one dot. So the other aspect to know is that within the additional dimensions, there is micro offsets, and then there are dispersion shapes. And underneath this, we have column, density, and directional. Column stacks them on a two-dimensional XY like bar. Directional will stack them one on top of another and any coordinate direction you define. Density is for like bubbles, and I think we have a circle as well, which is actually kind of fun. So if I click density, right away it's applying. Oh, sorry, go ahead.
It is fine. Sorry, the bell's rung again, so I'm going to have to go. But thank you very much. It was very informative, and I'm looking forward to trying it out and everything.
Absolutely. Thanks so much for
And
jumping
pass on
in.
to high school. Yeah, thank you. Have a good
Thanks.
day.
You too. Bye.
Bye.
Cool. How is this landing so far, JD? Is this helpful?
No, this is perfect. Yeah, this is exactly what I needed. Perfect.
Okay, great. So so after we had built it, essentially, so let me keep going here. The way that dispersion shapes works is that it's looking at how this reads. It needs to see, is the dot on the exact same spot? If so, move it around, like move it away, stop crowding each other. And that's essentially what dispersion does. And these are the options by which you're saying, as long as width, height, and depth, they're exactly the same spot, then do this thing. But you could also just have it defined along one dimension. So as long as they're on the same width, separate them X, Y, Z shape. And so if I select circle, then you'll see this, it's a Fibonacci circle that it's kind of fun. It's actually, I've been using a little bit more. There's something kind of fun about it. Yeah. So yeah, anyways. So the other one that's actually a very important drop down, but it's kind of hidden a little bit down here, is direction. So you have vertical and then horizontal and depth. Now you couldn't see the change when I went vertical to horizontal, but it did actually change. Let me move it to something else. But essentially what that means is like, in which direction is it applying these changes? And so you can essentially go any direction you'd like. So directional is stacking on top, and this is where you're defining the spacing as well as what direction it goes into. Now, the other aspect here is, so column, let me just quickly finish this off, is the 2x, or width and heights and how many dots essentially to have. I'm just going to skip over that here for now, because I kind of want to show you this is all underneath extended parameters. If I clear this whole thing, we've tried to create a shortcut by kind of naming some stuff and helping you get going, because we understand that those terms are, it's kind of, and I don't know if this really fully works yet. I have some issues with certain things, but essentially if we wanted to create those, bubbles again, I can click random bubble clusters and it will essentially start it. And it just puts in bubble clusters with the spacing amounts. Or I could change this to stacks, which we've basically tried to come up with names for like the different types of, if you saw it in the wild, what you would call it. And oftentimes it's vertical. So let me do this just so this makes a little more sense. So now I have these stacking. So it's stacking the dots on top of one another. Let's actually just look at year, and we'll take off depth too. Actually, no, let's change this to country. Okay. Country continents. Okay. So here's all the country continent combinations, this little matrix. And we have skyscraper selected, which essentially gives you width, height, and depth. So you can put the dots 3 by 3 across to create sort of your little cubes. And then these are how tall these are and the spacing in between the dots. So additional dimensions, dispersion is sort of like stacking and counting things is how I think of it. And one sort of insight more recently is that where that becomes really valuable, and I actually just posted one to our featured flows today that is an example of this. This one. So this is looking at, I'm just going to electricity sources by source in the US, and I'm skipping ahead here, but This is actually built with stacking dots.
Okay.
So to create a stacked bar chart in some sense, in an easier way, this I'll select sustainable. So this is going to be this graph up here is this swarm. So you'll see that I essentially have it set to scatter plot and the year. That is the only dimension I'm defining. And that's how I'm able to define the X position and have it be there. And so then it's everything else is underneath additional dimensions. I'm just using columns and I'm stacking them on top of one another. Now the way I manually created this axis because there is no axis defined when you do it that way, that this is a little bit of a workaround, which I can get into, but as a way to create these stacked charts, it's actually really powerful and nice for that. And I've seen a lot of benefit because the nice thing about this is just by default, now when I separate out like the depth dimension by source, it will by default not stack them because they're not on the same X plane. So yeah, it sort of is a nice way to do that. Okay, so back here, so it's probably one of the most powerful sections, but it's also can be very confusing. And one of the things that I think can be very confusing is sometimes you don't see what's happening. You click the button and then nothing changes. And a lot of times that's because the dots still exactly on the same spot as one another and you don't see them moving. This is usually what's happening. And that haven't fully figured out, but these structures where we're creating like the spirals and things like that, that is all done using cylindrical coordinates. And when I go in here, we'll see it's this radar chart, 3D cylindrical. The radius, which is the distance from this center line, is going between 0 and 0.5 meters out, based on the temperature anomaly of minus 1.5 to 1.5. So minus 1.5 is that center line right here. And then 0.5 meters out is equivalent to 1.5. That's essentially what that means. So I could adjust either of these and that will actually adjust the look of the graph itself. Now, how do you do that? That's a lot. So let me jump over to, I'm gonna go back to this one and click into cylindrical coordinates. So let's do life expectancy as the radius. And let me turn off this stuff. Actually, no, I can leave that on, sorry. Okay, so, all right, so no dispersion. All right, so these are cylindrical coordinates and we have the radius is going to be life expectancy. I'm going to start this at, let's say 0.5 and then go out a whole meter. And this is going to the min and max. I'm just going to set that equal to 0 and 100 just to have something that's pretty easy to calculate if I want to add an axis later. And so you'll see these are like moving around or moving out on the radius. And the reason they haven't gone around is we haven't defined the equatorial angle offset. And if we set that to, I should set that to. Normally, if you had like, if I had like month of the month, like 1 through 12, right. This is where you define that. I'll choose the year here, which should work. It's going from 1850 to 2020. And this is actually a bug that we should update. It by default puts 0.1 here, but it's actually not in radians. This is in degrees. So this should go 0 to 360. And then that will finish out the circle. So that's definitely a confusing spots. And it's doing it in this manner because I haven't defined the direction yet. So once I define that as depth or horizontal, I think it's horizontal, that's what I wanted, then it should start to look more correct. And
That's cool.
yeah, so there's quite a lot of possibilities, and I can go further and further into this. I think it's you know, as you experiment with it, please do reach out and just say like, hey, I'm trying to do this, you know, because we're still trying to make it a little simpler to wrap your head around it. And if you have any ideas, etc., yeah, let us know. But
Great.
sorry,
Yeah,
I was a little more than 5 minutes there. So.
No, that's awesome. Yeah, that'll get me started. I'll reach back out if I have more questions.
Awesome. Cool. Well, thanks so much, JD.